So my name is, can you say it like this? My name is Miri. And I'm going to be talking to you about algebraic geometry. I brought this book with me to the cafe. I was like, do you need to bring a book with you? And I just thought, bring this book that just makes me feel sick when I look at it, because it's got no freaking pictures in it. It's just like so many words and symbols that don't even freaking mean anything to me. Ugh, I feel sick even just talking about it to you right now. But I was looking at it and I was flicking through the chapters. The last chapter is called Systems of Curves on a Surface, and I thought, curves on a surface, that sounds like really, really cool and really groovy. So let's learn about curves on a surface. So
It is abysmal once you like already.
Yeah, after years of
I think
desktop Excel using the online.
the bit where I got stuck was on the second page. I made it to the second page. I made it to the top of the second page. I supposedly have a PhD in algebraic geometry, by the way, but this does not mean anything to me. But that's why we're trying to learn it here together. And so, systems of curves on a surface. How about I just write that on the board for now? Curves. My writing a pen is like a curve on a surface, isn't it? Curves on a surface. Okay, I feel better now that I'm writing, because it's not just like these abstract thoughts in my head anymore. It's actually making a mark on a surface. Mark on a surface? Mark. Is the curve the mark? Curves on a surface, marks on a surface. Well, should we build it up through dimensions? That's how we do it normally, right? Dimension 0. Dimension 0, demo, is just a point, right?
It's still saturated.
Dimension 1.
No, it's not. It's a super.
Oh, super. Oh, okay.
Does everyone know what dimension 1 is?
It's a bit warmer than the saturated.
A line, that's what they say, right? Dimension 1's a line.
It's not too.
Is it a line?
Like much.
I was about to ask that.
Or is a line just an approximation of a circle? Is dimension 1 really a circle?
It's about 144.
And it's not just one circle, it's like a whole
Oh, it's
Because it's
the entropy is.
plane of circles. That's complex plane. That's what we call the complex plane. Complex. There's the simple plane, I guess, is the real,
Yeah.
which is like,
what's that word? 2 points. If you just have 2 points, you can find.
or any one-dimensional. Well, but it's only half of the story. That's why. Do we want to talk about real and imaginary dimensions? We should talk about real and imaginary dimensions, shouldn't we? Because a lot of people don't know about that.
Something like that.
So, pick a one-dimensional subspace, real subspace, and look at this process. If you're looking at just what's a circle, and you're looking at the projection of the circle onto the real subspace, that's where you see like the sine wave, you know what I mean? It goes up and down. So I think that's the picture that maybe you've seen before. If you have like a point at angle theta. Should I draw it up here? There's an angle theta, you have this point here, call it e to the I theta. And then, you know, you have these two projections onto the real axis, and then people call this the imaginary axis. I guess the idea is like, if this is your real axis, then the other one's imaginary, but there's nothing special about, like, this could be your real axis and the other one could be imaginary. Is that true? Or is there something about There's something about the pairing, isn't it? It's like a left-hand rule. We don't need to go into that, but for people who know what these things are, there's a symplectic form which is going to come in later. I'll just write that down. Symplectic form. I think that has to do with Z times Z bar, and it's going to be a matrix, a Hermitian matrix. We don't need to talk about this right now. Why am I getting ahead of myself? Why don't we just talk about
That's right. The ideal assumption works when
dimension 2?
you're wet. Is it higher or low?
Okay, so dimension 2.
I thought it was height and flow.
How many directions are there in dimension 2? Well, there should be 2 sets of circles, right?
Oh.
So how do we draw 2 sets of circles?
Like anything atmosphere is probably.
I was gonna say I can have another color pen in my other hand. We can do 2 sets of circles like
Let's
that.
make that assumption and if it changes.
Okay, so this is one dimension, and then this is my other dimension. But I'm just drawing the same thing here, aren't I? So it's like this is what I was talking about there, complex conjugation. So is that right? Is it complex conjugation that switches? That's a homework question for you guys. Is that what that is, or is it something else? I know the answer, obviously, but because I'm the teacher, but I'm not going to tell you. You have to work that out yourself. No, I don't know the answer. We're all learning together. We need an orthogonal dimension, don't we? That didn't work because the 2 dimensions are basically, it's just 2 views of the same thing. It's like a mirror. That's like a mirror symmetry, right? Symmetry. We had a symplectic form before. Is that the same sim? It's somehow related, isn't it? There's another homework problem. It's an order 2 symmetry group, isn't it? C2. So we need an orthogonal direction. So I think I'm trying to think what are the 2 dimensions that are, should I just write this down? I'm going to write it down. So we need 2 orthogonal dimensions. And we need them to be complex dimensions, right? Circle dimensions. So the first example is electric charge and magnetism. That's like Maxwell's equations, right? Maxwell. And then I think the equivalent of that, which we feel in the body, is with walking. So when I'm walking, there's a big table in front of me, so I can't really move very freely. So, but I'm still going to try it with small steps. So I'm walking. So my right foot goes, my left foot goes. So there's the swinging of the leg, and then there's the twisting of the hips, isn't there? So leg, swinging, hips, twisting. That was not a good way of drawing it, was it? How do you draw the 2 orthogonal dimensions? Like that, and then the other one goes like that.
I know that error is 75%.
So that's the
Is that
twist,
2%?
and that's the swing. Anyway, it's 2 orthogonal planes. And the twists can get bigger or smaller, and the planes can get bigger or... And the... You know what I mean. We don't need to keep talking about that anymore. But I do need to have a drink of my drink before I freak out anymore than I currently am. Okay, everything's okay. Shall we continue, eh? So we're trying to visualize curves on a surface. So we're trying to get up to dimension 3. We're only in dimension 2 right now. Let's keep going. 3 is the magic number. If we can get up to dimension 3, that'll be quite nifty. Okay, so should we just keep going now? Let's just call that one done for now. Whatever. We're smart cookies, we can learn quick. I want to switch to black because I'm allowed to. Borrowed these pens from the information desk at the library. It's a very nice library here in Corvallis. I'm not even a student or a staff member, I just live here. And they gave me a library card, they let me borrow books. I'm not allowed to use the online catalogues, obviously. I can use the online catalogues, but I'm not allowed to use the online subscriptions. But my partner is a student here, so that's how we get around that. And I got a new job. I'm going to be working full-time as an AI engineer at a company that makes woodworking software. So I'm excited about that. I'll be starting that in, gosh, less than 2 weeks. I'm pretty scared, but I'm going to hopefully, not hopefully, I am. I'm going to have time for maths and I'm going to have time for work. Because I want to do a meaningful job, and I think this is going to be a meaningful job because it'll help people build houses so that they don't turn into mush. And then also this other work I'm doing is also a meaningful job, and I'm going to do both. That's what's going to happen. As it was written, so it shall be. Anyway, dimension 3. Dimension 3. Okay, so we need 3 orthogonal directions. So we already have the walking dimension, back and the forth, and then we also have the hips. So where can we get our third one? Are the hands going to be different again? The hands are different again, that's how we do it. So let's just say I have a simple hip circle, and simple back and forth. So this is a 2-dimensional period. 2-dimensional periods are elliptic curves. Is another word that maybe you've heard. It's a torus of dimension 2. So I'll just draw the picture of that. Have you guys seen this one? I love this drawing. It's a donut. And it's got a dimension there, and it's got a dimension there.
I think it's probably ideal. Like smalls and volume are kind of the same.
That's motion on a torus. Torus, 2 torus, or you might call it an elliptic curve.
Okay, now that I'm reading it, I think it's 1% because it says.
Yeah, 40 more.
Yeah, 40.
It's also an abelian variety.
Also, air is 21%.
Yeah.
And that's because it's got the group law.
It's also 80% relative humidity. So back to the
Addition.
Yeah, that was like.
So basically,
80%.
you know, if you have a point there and you have a point there, you can add them together, and they'll give you a third point. So it's a group under addition. That's why we use those words, which might mean something to some of you, and if they don't worry about it. So, dimension 3. What did we have? Okay, so we're doing our little back and forth. Okay, that's right. So we're a period on an elliptic curve. This is like, you can start harnessing work out of this. I feel like I'm, you know what I mean? I'm like digging something with a shovel, or maybe I'm like in a steam train, or one of those sort of energy extraction processes. I'll write that down because it seems important. Energy extraction. Change in... What's the word for energy? I was going to say E, but that's the same as we used E for that. Is it H? Something to do with the energy Hamiltonian? Probably get to that later. Anyway, I'm gonna have another drink of my drink. And I'm gonna do a little yawn. Oh. 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 I just took that. That was an accident. We'll fix it up in post-production. Okay, so dimension 3. Okay, okay, this is going to be fun. This is where the fun happens. Dimension 3. 3 is the magic number. So we're just getting slaving on the railroad. So look, I've got the... Is it 1 dimensions or is it 2 dimensions? It's 2 dimensions. But it's not going anywhere. What if I add a 3rd direction and I say stop? No, I'm not going to do that anymore. I'm going to do something different. I'm just going to dance around and... Have you seen that video of the guys when they take LSD in the army? And they're trying to get them to march around and everyone's just looking at the sky and having a good time. That's such a beautiful film. So dimension 3, that's where the magic happens. So 3 independent cycles. You know the ohm symbol? Is that right? Or does it go the other way around? Does it go like that? I can't quite remember how it goes. But I was thinking about it. It's got like 3 different circles in it. And you can go between 2 of them like that, and then you can go down like that. It's like a 3-dimensional like Lorentz attractor. If that means anything to someone. That's a torus. This is like a torus with 3 holes in it. It's a Genus 3. Why am I telling you these things? Because we're trying to visualize curves on a surface. So first we need to know what is a surface. And by curves on a surface, this is one of the bullshit things that they do here. I shouldn't say bullshit, but it's a sneaky trick because they say curves on a surface and then they say, should I write this down? I'm going to write this down because I can write it back over here in the start. They call it curves on a surface, and so they say affine 3 space. That sounds like 3D space, right? But then they also say it's over an algebraically closed field. What does that mean? Basically it means you have to have this circular structure. You have to be able to go between the 2 components. You have to have 2 basically symmetric and anti-symmetric components going together. That's what we call C. And then there's the other algebraically closed fields at the finite places, ZP, which we will definitely talk about later, and they're not that hard to understand. They basically correspond to the periods on these circles. So if I go 1, 2, 3, 4, dot, 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 And let's say that there's P of these, I guess.
Okay, I can start.
0, 1, 2, P minus 1. So that's like the first level, and then the next one you split each of these into P. So then totally there's P squared. You get this tower of level structures. It's called the Tate module. If that means anything to you, if it doesn't, don't worry about it. We'll definitely talk about all of this a lot more.
Like, we have some limitations on, like, what things can be, like, the overall.
I was just bringing this up to tell you about those. If you ever hear those words, it's tricky because curves doesn't mean curves and surface doesn't mean surface. That's what I'm trying to say. When they say curve, they mean dimension 1,
Airstream flow rate based on our ethylene stream flow.
but dimension 1 is already like
But other than that, like,
a surface. So I really should say
kind of just pick and start going through it.
surfaces. Is that right? We don't even really like that, do we?
So, like all the
No, we do
ratios
like
are
that.
fixed.
Yeah,
Surfaces on a hypersurface.
Yeah, there's a, yeah, 40% by
And then
C.
oxygen to the propylene is 2.25 ratio.
So if we have percent, we can
I don't know. Does that help anyone? Does that make anything better? Or
40%.
I feel like that's maybe a more modern way of putting it. These guys were the Italian geometers in the first half of last century, and they're a bit wacky.
Some molar flurry.
They made some silly mistakes because they couldn't visualize anything, but they were just super confident of their wonderful algebra, which I cannot follow for the life of me. Anyway, because I have ADHD and I don't take stimulants, and that's fine. That's my choice. My body, my choice. Anyway,
2.2
dimension 3, genus 3, 3D Lorenz. Are we visualizing 3 yet? Not quite. But we know that we need to have 3 independent things. Yeah, so the hips is 1.
Then the rest
So it could be hips and the 2 hands. That's a good one.
is like
Yeah.
So the hips and the 2 hands becomes a 3-body problem. So it's like the physics becomes chaotic and fucking cool. What are the different positions? That's the grammar of movement. I want to talk about grammar of movement, but maybe that's for next time. How long has the video been going for? Video's been going for 23 minutes, so do we want to talk about the grammar of movement? Let's do one more board, okay? I'm going to wipe off the board and then maybe we'll talk about the grammar of movement. What do you think? This is fun, isn't it? We're having a good time. I was crying. I was literally crying this morning. I was like, I don't want to go to school. And look, here I am at school. It's fun. School's the best now. School was the worst when I was a little kid because I had... Well, I was going to say it's because I had ADHD, but it was really because I was masking. Because I was masking a lot of things. Because they said that I couldn't be a boy girl, so I had to just pretend to be a boy, which was not fun. Let me tell you that. We don't have to go into details, but I'm sure you can imagine. And I wasn't allowed to cry at school. I had to be a big, strong boy. Which I am. But big boys cry too, don't they? Yes, they do. And if they don't, I'm going to fucking make them cry. No, I won't. But yes, I will, if they mess with me. But they don't. Because they know that actually everything's fine. I'm just having some sort of a flashback to school right now. But that's okay, because that's how it works. We're in this new situation that has some elements that seem similar, but some other things are different. And that's how we process trauma. Oh my god, can I have a bite of my lolly?